Hello everyone, thanks for watching this video. I am Monali and along with me Yash and Sudhakar have worked on this article that we have built around with KMIP protocol and Guardian Keys Lifecycle Manager. So as we know, banking sector is increasingly become a target for cyber attacks, primarily due to the vast amount of sensitive financial data it handles. So, with the rise of this digital banking, mobile banking, and financial technology, there is an urgent need for robust security mechanism to protect banking data, such as personal information, transaction details, and account numbers, etc. So this article provides insights how KMIP and Guardian Key Lifecycle Manager can offer a standardized secure framework for key management, addressing specific needs for banking applications while mitigating the inherent risk associated with REST. Unlike REST API, KMI provides a standardized vendor agnostic framework specifically optimized for cryptographic workflows. This ensures that seamless interoperability between different key management systems, reduces integration complexity, and enforces consistent security practices, making KMI more robust and secure for managing cryptographic material. This is the basic workflow. Here we have a banking application running on the client machine. So when a user perform transaction, the basic, the banking client application uses the transaction details, account numbers, which needs to be encrypted by the encryption keys. The application browser on client machine sends user data to the Python server to encrypt it. Here this Python server is the connection point between the browser and GKLM server. So this is where encryption operation happen. The application browser cannot do a KMIP call directly to GKLM server as it do not support this KMIP protocol. So we have to use a Python Java based server which support the KMI protocol as a bridge to connect web, mobile, or any type of application to GKLM server. So here GKLM is the key server. It is for so what it does, it centralize and automates the key lifecycle management process. So here the Python server sends the request to GKLM server for a key to encrypt the data, and then once the encryption completes, then the data stores at the database here. Now we'll quickly switch to our demo part. So this is the banking application, and we are now in user page where user can make transaction and bill pay. And now switching to admin page, so which can be used by the security admin. So we can see various key operations are here, like create key, fetch key, rekey, delete key. And if we click on the current key, so it will show the encryption key that is used for current and upcoming transactions. Okay, now let's go ahead and create a new key. So I'll click on create new key tab and generate new key. Here we can see the new key has been created with the key ID. Just notice this key ID. Uh, so we can see the key ID is ending with the letter F5D7. So let's verify from GKLM if same key has been present to confirm the GKLM and client application communication through KMI protocol. I have logged into the GKLM server, and we can see the key with same ID is present in GKLM server end for a KMIP client. Security admin can fetch the key details by providing the key IDs here from application itself. Um, here you can click to fetch key details and enter the key ID. And we can see the key information here, such as cryptographic algorithm, key length, initial date, and many more information for audit purpose. When the key gets compromised and no longer needed, it can be deleted from application itself. So just put the key ID and click on delete. So it will get deleted from both application and GKLM. And now let's explore rekey option. So rotating key regularly reduces the risk of attackers accessing large volume of sensitive data. So so we'll go ahead and check the current set key. So just note down the current set key. Now we'll click on rekey tab to rotate the current set key. So here we can see the new key has been generated and the old key will be removed, and if we check in current set key we can see the same key is reflecting here. So just note down this new key. Now we'll make transaction on user page so that the upcoming transaction will be encrypted by the new key. So here in recipient I'll enter a name and I'll enter the amount, then send. So this transaction is in process, and we can see here this transaction completed, and here we can see the transaction ID. To verify this, if this ID is encrypted on admin page or not, we can go to the admin page and view all transaction. If I'll enter the old key here, then it won't get encrypted. If I'll enter the new key, it will get encrypted. Let me show this demonstration. Here I'm using the old key to view the last transaction. So here I can see the transaction is in encrypted format. So now I'll try with the new key after the key rotation. So so I have just put the new key, and if I try to decrypt it, here we can see the transaction ID and the amount that sent in transaction. So that's all about the demo. Thanks for watching.